Until now, we have seen motion along straight, broken, and curved paths. Now let us focus on one especially important curved path, a circle. Imagine the tip of a clock's second hand. As the hand turns, its tip does not move in a straight line. It traces a circle. This motion raises two different questions. First, how far does the tip actually travel? For distance traveled, we follow the path. On a circle, that path is an arc. After one complete revolution, the distance traveled is the circumference, s equals 2 pi r. After half a revolution, the distance traveled is half the circumference, s equals pi r. After 1/4 of a revolution, the distance traveled is 1/4 of the circumference, s equals pi r over 2. Distance traveled follows the circle. It runs along the arc. Displacement asks a different question: where did the object start, and where did it finish? Displacement does not follow the arc. It is the straight arrow from the initial point to the final point on the circle. Watch both quantities together. The green curve shows the actual path. The blue arrow connects the same start and finish directly. The distance traveled is the arc length. The magnitude of displacement is the straight separation. Now imagine a fly sitting on the tip of a second hand that is 20 centimeters long. The fly remains there for half a minute, so the hand turns through half a circle. The radius is 20 centimeters. A complete circumference would be 2 pi r, which is 2 times 20 pi, or 40 pi centimeters. The fly travels only half of that circumference. Therefore its distance traveled is s equals 20 pi centimeters. But the magnitude of displacement is not 20 pi centimeters. After half a revolution, the fly is on the opposite side of the circle. The straight line from the initial point to the final point passes through the center. It is a diameter. The diameter is 2r, which equals 40 centimeters. Therefore the magnitude of displacement is 40 centimeters. For this motion, the fly travels 20 pi centimeters along the arc, while its displacement magnitude is 40 centimeters across the diameter. This also reveals the greatest possible displacement magnitude between 2 points on a circle. As the final point moves around the circle, the straight separation changes. It becomes greatest when the final point is exactly opposite the initial point. Those 2 points are separated by a diameter. So the magnitude of displacement can never exceed 2r, and its maximum value is 2r. Now let the object complete a full revolution. It travels the entire circumference, so the distance traveled is 2 pi r. But it finishes at the same point where it started. The initial and final positions coincide, so the magnitude of displacement is 0. The same idea applies to a person who walks once around a circular park and returns to the starting point. The person has walked a real distance, but the change in position is 0. The physical meaning is simple. For circular motion, distance traveled measures how much of the circular path the object covers. Displacement measures the straight change in position from start to finish. So never calculate the circumference automatically when a problem asks for displacement. First look at what the question requests. If it asks for the length traveled around the circle, follow the arc and calculate distance. If it asks for the straight separation between the initial and final positions, draw the direct arrow and calculate the magnitude of displacement. The same reasoning works for clock hands, circular tracks, and objects moving in orbit. Trace the actual path for distance, and connect start to finish for displacement. If this explanation helped, please like the video, subscribe to the channel, and leave your physics question in the comments. We will do our best to answer it.